Hi everybody, how's it going? Today we will have problem number 34. Problem number 34, it's to read a number and check if it's a prime number or not. Prime number can only divide it on one or on itself. We will take number from the user through the console screen and we want to check this number that we read it through the console screen. It's a prime number or not. And the prime number, we can just divide it by itself or on one. Okay, so if the user insert, for example, the input 5, the output should be prime because number 5 it's a prime number. If the user insert or the input of the user is number 6, the output it will be not prime. And if the user insert number 3, the output it will be a prime. And now you will think all the odd numbers are prime numbers. No, the odd numbers like 5 and 3, it's give us here prime, the output is prime, and they are odd numbers. But not all the odd numbers are prime numbers. For example, you have 15, 21, 25, those odd numbers, but they're not a prime numbers. And at the same time, we have an even number, which is 2. It's a prime number. So not all the odd numbers are prime numbers. And now let's go to Visual Studio to convert these requirements, these problem requirements, into code. We'll see how we're gonna solve this problem there on Visual Studio. Let's go. All right, this is our solution of problem number 34. It's to read a number and check if it's the number prime or not. Okay, the first thing we will do is to create an enum. We name it en, is the prefix prime or not. 1 represent prime, 2 represent not prime. And after that, we use our generic function. We just change a little bit its name from read numbers to read positive numbers. And it's same, it has in its parameter the question to customize the question down in the main function as we want. Let's open it, takes the number, we do initial value and see how to question, store it inside the number. After we display the question for the user on console screen, we store it inside number variable. After that, we return the number. Because it's integer function, we have to return one value. And all of them, if you see here, integer, because all the prime numbers are integer or clean numbers without decimal fractions, and all the prime numbers also are positive numbers. Okay, there is no prime number, negative number at all. And after that, we build another function. We name it check prime number or not. This function, it's from a user-defined data type, from the name of the enum. Okay, this function is user-defined data type function. It's like in the end data type, as we say, the name of the enum, the struct. We can use it like integer, void, like any data type. So we name this function check prime number or not. It takes the number. Let's say the user insert number 10 and we store number 10 inside this number. So let's open this function and see what's inside it. Perfect. We define integer data type and we declare variable. We name it h. H stands for half. I just name it h, but it stands for half. Okay. Equal round number divided 2. We said the user insert number 10 and we store it inside number. So number, which is 10 divided 2, it will give us 5, and 5 we store it inside h. We do here rounding in case the number have some decimals or fraction. We need to make it just a clean integer number. For that we do rounding. Like if it's 5.5, we want to make it 5. If it's 6.5, we want to make it just 6. If it's 3.5, we just want to make it a 3. So we take the number, which is stored inside the number 10 as the user insert on the console screen. We divide by 2 to give us 5. We store it inside h, which is stand for half. So we have the half of the number now that the user inserted. We'll use for statement starting from for keyword integer counter equal 2. Why starting from 2? Because any number will divide it by 1. It will be useless testing to check if the number prime or not. So to check this number prime or not prime number, we will start from 2. So integer counter equal 2, counter less than or equal h, 2. This is the condition now. This is first the initialization of the for loop. You already know this. And after that, we go to the condition. Counter store inside number 2, less than or equal h. H store already inside the number 5 because the number we divide by 2, the number was stored inside number 10. When we take it from the user to the console screen, we divide by 2 here up. So it gives us 5. 5 is stored inside h. So h now stored inside it number 5. 5 less than 2. That's true. The condition is true. So we'll go inside the for loop statement to check what code inside it. Inside the for loop statement, we have this if statement. If number mod counter equal 0, return not prime. If the number, not half of it, if the number itself that the user inserted through the console screen, mod 2, because counter stored inside the 2, equal 0, give us 0. So this is not a prime number. All right. Else it's a prime number. Here after the for loop, we write return en prime or not, colon prime. If it gives us something else than 0, so it's prime number. And in the end, we have this procedure, void print prime or not prime. It takes the number. After we already check it if it's prime or not prime, we just print it. Switch case, we use switch case statement. Okay, we take the number. We said check prime number or not. the previous function that we just explained right now, and we give it the number. So all this expression here inside the switch case, it will give us prime or not prime number. And after that, we say case 1, if the number is prime, please print for me this string, the number is prime, and break. Exit me or take me out of this procedure. Case 2, if the number not prime, print for me this string, the number is not prime, and also do break statement. Don't forget to use break keyword, because if you not do break keyword here in the beginning, the compiler will print for you the number is prime, and also the compiler will go complete to print for you the number is not prime, because you didn't use break keyword. If I didn't use break, the compiler will not go out of the procedure and complete to print for you the second string or text, and this is a wrong solution, so you will face a problem. And in the end, here in the main function, we just call it. We said print prime or not prime. We put in its parameters read positive numbers, and in its parameters of the read positive numbers, we put the string, which is the question, because we want to customize it as we want. We said please insert a positive number. Let's do run to check it out together. Perfect. Once you did run, the compiler display for us this question, please insert a positive number. Let's say it's 5. The number is prime because 5 is a prime number. Let's do run again and insert a different number. For second time we did run, please insert a positive number. Let's say it's 6. The number is not a prime, and this is correct. Number 6 is not a prime number. Look, if you forget here to do a break statement and we did run, the compiler will print for me the number is prime and the number is not prime. If you insert a prime number, the compiler will print for me both strings, which is a wrong solution. Perfect. This is for the third time we did run. Please insert a positive number, but we delete the break keyword. So let's say it's 5. Look, the compiler print for you the both strings. Why? Because we forget here break keyword. Compiler print for me the number is prime. It's correct. Number 5, it's a prime number, but instead take me out of the function or procedure complete to print for me the second string. The number is not prime, which is this second string here, because we didn't use break statement or break keyword. So that was the problem of today. Problem number 34 was about check the number if it's prime or not. See you next lesson, next problem. Ciao.